Indeed, the physics components are the main tools to create a simulator. In this clip, we want to know how we can use the physics components of Unity in our project. In the last clip, we have talked about how we can add 3D models or 3D assets into our project. In this clip, we want to talk how we can use the components physics of the Unity engine. So, I want to make an example for using the components of physics here by adding an object, for example, cube here, and as you can see, as a default, it has something it's called box collider. This thing is very important. This is a very useful component from the physics family components of Unity. Collider means that if I hide the mesh renderer, as you can see, we can see a hidden cube with the green lines as a physics collider. It means the colliders will be the trigger of our hit or the reason of rigid body or in fact the intensity of our object. Something like without box collider our object is visible, but it's not sensible. In fact, the collider is the sensitive option of our object. We have various types of colliders: box collider, sphere colliders, capsule collider, or even the mesh collider. As a default of box collider, we will see the box collider in here. If I add sphere, it has sphere collider. Look at this. And if I add something else, capsule, here we have capsule collider. Okay. As a first part of our video, we want to add something important from the physics components family. Its name, rigid body. Rigid body is a very useful and common component of the physics, and it is equal gravity. So if you want to simulate gravity to your object, you need to use rigid body. And also, if you want to write some scripts which using the colliders, your object must have a rigid body to be able to sense any actions or any hits on the object. For example, we put our main camera in front of this cube, and we will see what will happen if we play the game. Our cube has rigid body without any changes in the rigid body component. It's playing the game. It's falling down. Does exactly look like if our object has gravity. If I remove it and play the game, it will stay here without any reaction. But if I add rigid body, it will fall down. Now let's change some parameters of the box collider initially. For example, it is an object. It has a very sensible meshes, and we can set the size of the box collider with the size of the mesh. But if our object has not very common meshes. For example, here, this house, we want to add a collider in here, or this object, this car object. We need to go to the component here, physics. We will have a family of the collider: box collider, sphere collider, capsule collider, mesh collider, wheel collider, and train collider. In fact, this part of our scene is train, has train collider. Without train collider, our object is falling down. If they have a rigid body, they falling down and they go inside of the train and pass it and falling down forever. But we need to keep train collider on. So we need to add a component. It's called, for example, box collider. As you can see, it is inside of it. If we want to change the size of it, we can change it in here. Something like this, and like this, and like this. And also we can change the position of collider. Can put it in here. For example, I decrease the size of Y parameter and put it here. Also, we have another solution for edit the box collider size. It's called edit collider. As you can see, it has some angles. To change it, it is very easier than other way, because you can change every angle of the collider separately, and it is very easy for edit the box collider size. Okay. Another important thing is trigger. In the future, I will talk more about the is trigger. Once we want to do some actions whenever we reach this object or touch this object, or even we put some triggers, invisible triggers in our scene, we can do some we want to do some things in our simulation scenario, so we will use triggers. So I will keep it in here without any talking more about it. In the future we will talk about it, but keep it in your minds. Once you check on the triggers, the rigid body will not work for it, and also the objects can hit and go inside of the object. Without the rigid body, without the trigger, and check off the trigger, the other objects which have a rigid body can hit this object and cannot go inside of it. But if this car's trigger is on, the other objects will go inside of the car. So remember, your is trigger must be off. Okay. This is the all information about the box collider. For example, we can remove the box collider and add some other types of colliders in here. For example, mesh collider. The mesh collider is a system for setting the colliders with the size of the mesh. In fact, look like this. Oh no, we have to add to the body because it has mesh renderer. And mesh collider in here. As you can see, it's tried to set the collider size automatically with the mesh, but it is not optimized at all, especially if you have lots of objects in your scene. Don't use the mesh collider for all of them. Use the mesh collider for only that objects which has priority to have more details in the collider. For example, this one for tree. or for rocks or other things, and that's not very important in the details of the position of colliders, I propose to use simple colliders components. For example, box collider, I don't know, sphere collider, capsule collider. Don't use the mesh collider for all of these objects because it's using the performance a lot. Okay, as you can see, it has its trigger as well, so remember, don't check on the is trigger. Yeah, okay. Forget the mesh collider and the core and get back to our cube. Okay, we want to talk more about the rigid body. So right now, let's play again, and we will see the impact of the rigid body in here. Control S for saving automatically, and let's wait for the loading, and after that we play the scene, and we want to see what will happen once we play the game and rigid body works for this cube. After that we want to change some parameters and check them with more detail. Okay, you can see the diversity of the falling down of the cube, so we can change it. In fact, in here we can change the math. We'll see what will happen. It's heavier than before. Or even we can change the drag. For example, put the 5. It will be slower. It seems our gravity is less than 9.8 in our train. It seems we are in Mars, not in the Earth. Or even, I don't know, 10. It will be so slow. Perfect. Also, we can change them in real time. It works because the function of rigid body is updating itself per frames. Also, we can change the angular drag. It is the same look like this, so I don't want to talk about it more. Let's talk about use gravity and is kinematic. Some components use the gravity and a rigid body for heating the objects or for calculating the physics. So we don't need to have gravity specifically. We need to have something rigid body for component of the physics, but without impact of gravity. So we will check on the is kinematic of this component, and as you can see, it has rigid body without falling down. So we can check on it. It is the same for use gravity as well. Okay, another important thing is maybe useful for you is freezing. With the rigid body, we can freeze an object in a specific angle or a specific position. For example, we can freeze this object in parameter y. It is not kinematic. It has mass, drag is 0, but it will not fall down. Look at this. To stay in here, I check off. It's falling down. For example, let's change our object from cube to sphere and put our sphere in here to better see the gravity impact. For example, in here, and add our box collider from here. Rigid body. Oh yeah, it has a sphere collider, excuse me, and add the rigid body to the sphere. So I want to change the rotation to 0, 0, 0 for better understanding the freezing the rotation. Okay, 0, 0, 0. Perfect. And if I rotate, freeze the rotation X, and let's to play, we'll see what will happen. Look at this. It's not works. Maybe maybe my component has a problem in the freezing, but anyway, we can freeze the rotation, we can freeze the position with this one, but we can use another component for this one. It is not very high priority of our tasks. I want to talk more about the components of the physics. If I want to use cube in here and make it this one, perfect, and make it something like this, and we will add component physics in here into the it and make this kinematic on. Okay, we will right click and duplicate. It's making exactly the same object and the same components but with another object. Look at this. This new object has rigid body, box collider, and it is kinematic as well. So I don't want it, and put it something like this. Perfect. Now I want to talk about another physics component. It's called, at first I need to click on someone, okay, and hang joint. If we want to create something look like a magnetic impact between two objects and magnetic connections, we will use joint components. In here, I want to talk only for hang joint. In the fixed and spring, we will talk about them later, maybe. Okay, add the hang joint in here, and as you can see, it has a lot of parameters, but I propose to keep them as a default because it's very complicated, and changing them maybe make another impact for our connection. So the important point for having the hang joint is both objects must have rigid body. It doesn't matter is kinematic is on or is kinematic is off, but they must have rigid body. So okay, as a parent, this object is a main reliable object. We will add hang joint, then drag and drop connected body to it. Perfect. Now we play the game. Perfect. It has been joined to our cube 1. If I change it, it will move for it as well. Rotate it, or let's look like pendule. It's perfect. And in here, so we can freeze the rotation. Perhaps it works. Look at it. Let's try to freezing. and we can put the sphere above of this cube. It's falling down. Okay, it is the basic tutorial for the physics components of the Unity. So we can use these components and other advanced components of the physics and simulate all the physics situation and rules for our simulator. Okay, let's go to the next step.